Okay, let's talk about the SDLC. It stands for Software Development Life Cycle. Essentially, it's like a blueprint or a roadmap that guides us through building software. It breaks down the entire process into manageable stages. First, we gather requirements, figuring out exactly what our users need. Then comes design, where we plan how everything will work together. Next is implementation, which is actually writing the code. We rigorously test it to make sure there aren't any bugs. After that, we deploy the software, get it out there for everyone to use. And finally, we continuously maintain and improve it over time. It's important because it helps ensure projects are completed on time, within budget, and meet user expectations. Okay, let's talk about the SDLC. It's basically a roadmap for building software. It's not just about writing code, it's a whole process from start to finish. Usually, you'll go through phases like gathering all the requirements, figuring out exactly what the users need, then designing how the system will work. Next comes coding and building the actual software. Critically important is testing, making sure everything works correctly before releasing it. Finally, there's deployment, getting the software into people's hands, and ongoing maintenance to keep it running smoothly and add new features as needed. Okay, so let's talk about the different approaches we can use when building software. The waterfall model is a classic. It moves through phases one after another in a linear way. It's straightforward, but less flexible for changes. Then there are agile models like Scrum and Kanban, which focus on working in short cycles and getting constant feedback from the client. The V model links development stages to testing, making sure we're thoroughly tested at every step. And finally, the spiral model is great for complex projects where you need to manage risk carefully. Okay, let's talk about the waterfall model, a really classic approach in software development. It's like building a house. You need a plan up front, and you follow it step by step. The process is broken down into distinct phases: requirements gathering first, then design, followed by implementation, testing, and finally deployment. It works best when your requirements are really clear and unlikely to change once they're set, and it's particularly useful for projects that aren't overly complex or have strict documentation needs. Basically, if you know exactly what you need from the start, waterfall can be a solid choice. Okay, let's talk about the waterfall model. It's a really traditional way to build software. Think of it like a cascading waterfall. It has some great advantages. It's super simple to understand and follow, with clearly defined stages at each point, making it easy to track progress. It works best when your requirements are pretty solid and aren't likely to change much. But be warned, it can be really inflexible. If you need to make changes later on, it's a major headache. And because testing happens so late in the process, if you find problems, fixing them can be expensive and time-consuming. So, while waterfall is good for stable projects, it's not ideal when things are uncertain or requirements might shift. Okay, let's talk about Agile within the SDLC. Think of it as a really dynamic approach compared to older methods like waterfall. Instead of planning everything up front and then building in stages, Agile breaks down the project into short cycles. We call them sprints, usually around 2 or 3 weeks long. It's all about constant communication with the customer, getting their feedback regularly, and being adaptable if things change along the way. The focus isn't on massive documentation, it's really about delivering working software at the end of each sprint. There are several different frameworks that fall under the Agile umbrella, like Scrum and Kanban, but they all share those core values. Okay, let's talk about how Agile differs from the classic waterfall approach. Think of waterfall like building a house with a very detailed blueprint. You have to finish the foundation before starting the walls. It works well when you know exactly what you want from the beginning. But if your client wants to change their mind halfway through, it can be really tricky and expensive. Agile is much more flexible. Instead of one big plan, we work in short cycles called sprints, like building a room at a time, getting feedback after each one, and adjusting as we go. It's all about adapting to changes and delivering value continuously. Okay, let's talk about why Agile is such a big deal in software development. Think of it this way: instead of trying to plan everything out up front like you would with waterfall, Agile lets teams be really flexible and adapt as they go. It's great for dealing with changing customer needs or shifts in the market. Because you're delivering working pieces of software regularly, you get value to your users much faster. And because the team is constantly talking to the client and getting feedback, everyone ends up happier, both the developers and the customers. Okay, let's talk about the iterative model. It's a really common approach in software development. Basically, instead of trying to build the entire project from scratch at once, we break it down into smaller chunks or iterations. It's like building with Legos. You start small, test what you have, get feedback, and then add more pieces. Each iteration delivers a functional piece of the software, and we continuously refine it based on that feedback. This approach helps us catch problems early, deliver value faster, and keep our customers happy because they are involved throughout the process. Okay, let's talk about the V model. This model is all about connection, specifically connecting each stage of building software with its corresponding test phase. It's shaped like a V, with one side representing development activities and the other mirroring them with testing tasks. So, you start by clearly defining what needs to be built, then design it carefully. As you're building it, you'll be doing acceptance testing to make sure it does what the client wants. Then, as more pieces come together, you'll do integration testing and so on. The V model really emphasizes that testing isn't just a final check, it happens throughout the entire process to keep things moving smoothly and ensure quality from the very beginning. Okay, let's talk about the spiral model. It's a really interesting approach to software development that puts risk management front and center. Unlike a simple, step-by-step process, the spiral model cycles through 4 phases: planning, where we define our goals and constraints; risk analysis, where we proactively identify potential problems, anything from technical challenges to things like changes in requirements; development; and evaluation, which is about building a prototype and checking it against what we've planned; and finally, iteration. We review the results, fix any issues, and then start planning for the next cycle. Because risk is so important, the amount of work done in each phase depends on those risks. The spiral model shines when you're dealing with complex projects where things aren't always clear from the beginning. Think big projects like building a new aircraft or a medical device. Finally, during an interview, it's good to ask how they prioritize risk assessment to really show your understanding. Okay, let's talk about the Big Bang model in SDLC. Think of it like a really focused sprint. We're all going full speed right from the start. It prioritizes getting a working product out quickly, so we focus on the most important features first. Design and coding happen together, and testing is integrated into every step. Because requirements are generally stable with this model, you don't need tons of documentation. It's great for projects where you know exactly what you're building, but can be tricky if things change a lot along the way. Okay, let's talk about what you'll actually be producing at each stage of the SDLC. First up, during requirements gathering, you'll need a solid project requirements document, basically a detailed outline of everything the software needs to do. Alongside that, you'll likely create use cases or user stories, and maybe some early wireframes to visualize the basic layout. Then comes design, where you'll be documenting your system design, crafting a database schema, and building out more polished UI/UX mockups alongside technical specifications. The implementation phase is all about writing code, creating unit tests to ensure each piece works correctly, and building those final deployable artifacts. Testing follows with a comprehensive set of test cases, detailed bug reports, and results from integration testing. Deployment involves actually getting the software live. You'll need a deployment plan and updated configuration documentation. Finally, maintenance is an ongoing process involving updates to the code itself, keeping your documentation current and tackling any new bugs that pop up. Okay, let's talk about requirements gathering, a hugely important part of SDLC. Basically, it's all about figuring out exactly what the client wants the software to do. We use lots of different techniques like talking directly to stakeholders through interviews and workshops, and sometimes even sending out surveys. All those collected needs are then documented clearly, often in things like user stories or functional specs. It's really important to prioritize these requirements too, so we know what's absolutely essential versus what's just nice to have. And finally, we constantly check that the gathered requirements actually make sense and can be built technically. It's all about ensuring alignment throughout the process. Okay, let's talk about the importance of a feasibility study in our software development life cycle. Basically, it's like doing your homework before you start building. It helps us figure out if this project is actually achievable, not just technically possible, but also financially smart and realistically workable. We look at things like whether we have the right skills to build it, if it'll be profitable, and whether we can even support it once it's live. It's a really important step for preventing costly mistakes down the line. Okay, let's talk about system design within the SDLC. This phase moves us beyond just saying what we want the software to do. It's all about figuring out how we're going to build it. Essentially, we create a detailed blueprint of the entire system, considering everything from high-level architecture down to specific components and data structures. It involves creating diagrams showing how different parts of the system will work together. We validate the design against the initial requirements, ensuring it's not only functional but also scalable and adaptable as needed. Okay, so when we're talking about SDLC in design, it's really important to understand the difference between high-level design and low-level design. Think of the HLD as your big picture blueprint. It outlines what needs to be built and how the different parts of the system will generally interact. It's a strategic overview. Then you have the LLD, which is like zooming in really close. The LLD focuses on the it gets into the details of things like data structures, algorithms, and exactly how each component will be coded. Basically, the HLD tells you what to build, and the LLD shows you how to build it. So, after all the planning and design, we move into the actual coding. This is where developers start building the software based on what we've outlined. They're writing code, piece by piece, ensuring each part works independently through unit testing. It's not just about getting it done, it's about doing it right. That's why code reviews are so important. A fresh pair of eyes can catch things you might miss. And of course, bugs happen. Debugging is a big part of this phase, and fixing those errors ensures the software runs smoothly. Okay, let's talk about testing within the SDLC. It's really important. Throughout the process, we use different kinds of tests to make sure everything works smoothly. First, we have unit testing. That's when you check individual pieces of code on their own. Then integration testing verifies that all those pieces work together correctly. System testing takes a step back and looks at the whole system as one thing. Acceptance testing is done by the users or clients to see if it meets their needs. Regression testing ensures that any new changes don't accidentally break anything existing. Finally, we do performance testing to check how fast and efficient the software is. Okay, so let's talk about the deployment phase. It's a really important one. It's easy to think of it just as putting the software online, but it's actually much more. It's the moment when all your hard work pays off and users finally get to experience what you've built. A successful deployment builds trust, helps realize the business value of the project, and sets the stage for ongoing stability. It also gives us that vital feedback loop. How are people actually using it? So, during deployment, we need to think about things like having a plan if something goes wrong, a rollback strategy, making sure we're closely monitoring the system, and doing performance tests before launch. Okay, so let's talk about the maintenance phase. It's often overlooked, but it's absolutely vital. After you launch your software, things don't just magically stay perfect. This is where you focus on keeping everything running smoothly and adapting to changes. It's broken down into a few key types. Corrective maintenance deals with fixing bugs that users find in the field. Adaptive maintenance ensures your software works with new technology like updated operating systems or hardware. Preventative maintenance adds improvements, new features or tweaks to make things easier to use. And finally, preventive maintenance is about proactively preventing issues from arising in the first place by cleaning up code and improving documentation. Let's talk about how the software development life cycle helps us create better quality software. Think of it like building a house. You wouldn't just start laying bricks without a plan, right? SDLC does exactly that for software. It forces us to really nail down what we need from the very beginning. Clear requirements mean fewer misunderstandings later on. Plus, by integrating testing throughout each stage and actively managing risks, we catch problems early. Version control systems make sure changes are handled properly, preventing chaos. Basically, SDLC isn't just about building something, it's all about delivering a consistent, reliable solution that meets user expectations. Okay, so let's talk about stakeholders. They are absolutely key to any successful software project. Think of them as anyone who has a vested interest in the finished product. We've got customers telling us what they want, end users who will actually be using it daily, business analysts figuring out exactly what needs to be built, developers coding it all up, testers making sure everything works properly, project managers keeping things on track, and of course management giving the overall direction and funding. Each stakeholder group plays a different role at each stage of the SDLC, from gathering requirements right through to deployment and ongoing maintenance. Getting their feedback consistently is what makes a project truly successful. Okay, let's talk about how we handle changes to requirements during software development. It's completely normal and frankly expected that things shift along the way. The key is a structured approach. First, you need to really understand how a change will affect the project scope, timeline, budget, and quality. Then, using a formal change control process, like a change request form, you evaluate if it's worth pursuing. Prioritization techniques like methodologies can help you focus on what's truly important. And most importantly, keep everyone in the loop. Finally, linking requirements to the different stages of development through version control ensures everything stays connected and traceable. Okay, let's talk about the tools that make an SDLC run smoothly. There's a whole toolbox out there designed for this process. You'll definitely want to be familiar with version control systems like Git. They are fundamental for teams working together on code. Project management tools like Jira, Asana, and Trello help keep things organized by tracking tasks and sprints. Then you have your CI/CD pipelines, Jenkins, GitLab CI, Circle CI, which automate the whole build, test, and deployment process. Don't forget testing tools like Selenium or JUnit for making sure everything works as expected, plus collaboration platforms such as Slack or Microsoft Teams to keep everyone connected. Let's talk about how version control fits into the software development process. Think of it as your time machine for code. You can always go back to a previous state if something goes wrong. Version control systems like Git are absolutely vital at every stage, from figuring out what features people want all the way through deploying and maintaining the finished product. They help teams stay organized, collaborate effectively, and make sure everything is tracked properly, reducing risks and making development smoother. Okay, let's talk about requirement specification documents. Think of them as the blueprint for your software. They are a super detailed description of what the program needs to do, not how it should do it. They break down what we need into functional requirements like specific features and non-functional requirements such as performance or security. You'll often see user stories, basically short descriptions from the customer's point of view and use cases that outline how users interact with the system. In an interview, they'll want to know you understand these components and how to ensure they're clear and well-defined. Okay, let's talk about test plans. They're super important when it comes to software development. Think of a test plan as your detailed guide for making sure your software is top-notch. It covers everything: what you'll be testing, the specific goals you're aiming for, what kinds of tests you'll run like unit tests or integration tests, and even who's involved and when things need to happen. A good test plan helps minimize risks, boosts quality, saves everyone time and money, and makes sure everyone is on the same page about expectations. Let's talk about risk management within the software development life cycle. It's not just about spotting problems, it's about being prepared for them. Think of it like this: you want to identify what could potentially throw your project off course, then figure out how best to deal with those things. Risks can lead to all sorts of issues, from expanding the scope of the project beyond what was originally planned, to going over budget and missing deadlines, even impacting the quality of the final product. A good SDLC approach involves identifying those risks early on using things like brainstorming sessions or looking at past projects, then assessing how likely they are to happen and how badly they'd affect you. Finally, we create plans to either avoid those risks entirely, mitigate their impact, transfer them to someone else like an insurance company, or simply accept that they might happen. Okay, let's talk about how we figure out how long and how much a software project will take. It's really important to get this right. First, you break down the whole project into lots of smaller pieces, tiny tasks that are easy to manage. Then, use different techniques like PERT, which looks at best case, worst case, and most likely scenarios. Another good one is 3-point estimating, where we take an average based on those different possibilities. Of course, don't forget the people involved, team size, skills, and whether they're available to work. And always add a buffer, just in case things go a little sideways. Finally, it's key to regularly check our progress and adjust our estimates as we go. Let's talk about prototyping. It's a really crucial part of the software development life cycle. Essentially, a prototype is like a first draft of your software. It doesn't have to be pretty or fully functional, but it's there to help you and your team get things right from the start. Prototypes can range from simple hand-drawn sketches to more sophisticated digital mock-ups. They allow you to gather feedback early on, making sure everyone is on the same page about what the software should do, and helping you catch potential problems before a ton of time and money are spent actually building it. Okay, so let's talk about requirements, the foundation of any good software project. We need to distinguish between functional and non-functional requirements. Functional requirements tell us what the system needs to do. Think of them as specific actions or behaviors like logging in, adding an item to a shopping cart, or calculating something. Non-functional requirements, on the other hand, describe how well it does those things. They're about qualities and constraints. We're talking performance, security, usability, accessibility, basically anything that isn't directly tied to a specific action. Okay, let's talk about how we decide what gets built first in a software project. Prioritizing requirements. It's really important to do this right because it directly impacts the success of the project and keeping everyone happy. There are several techniques you might encounter. One popular method is MOS code: W must have, should have, could have, won't have. This helps categorize features based on their importance. Another common approach is a value vs effort matrix, where we visually map out features based on how much value they bring to the user and how difficult they are to implement. Then there's the Connor model, which looks at different types of customer needs, things that delight users, things that just need to work well, and things that don't really matter. And finally, we can consider cost of delay, figuring out what happens if we postpone a particular feature. Remember to always gather input from stakeholders, assess risks, and consider any dependencies between requirements. It's all about making smart choices. Okay, let's talk about CI/CD. Basically, it's a super important part of how we build software now. Think about waterfall. It can take long time to get something out the door. CI/CD is all about automating that process. We have continuous integration, where developers constantly merge their code and automated tests check everything's working. Then comes continuous delivery, which makes sure those updates can be released automatically without tons of manual work. This means we ship faster, reduce errors, and help our teams get more done. Let's talk about a really common situation in software development. You get a requirement that's not quite clear. Don't panic. First thing I always do is immediately try to clarify, asking questions until I truly understand what's being asked of me. Then, if it's a big chunk, I break it down into smaller parts, making them easier to tackle. Understanding why the requirement exists, what problem we're solving, and who benefits can also be incredibly helpful. If I need to make an assumption, I document it clearly so everyone is on the same page. And sometimes, a quick proof of concept can help validate my understanding before committing to a full solution. It's all about clear communication and proactively addressing any confusion. Let's talk about why documentation is so vital in SDLC. It's not just about writing things down, it's truly about ensuring everyone on the team, from developers to testers to stakeholders, is on the same page. Good documentation improves communication, makes it way easier to maintain the software as time goes on, and ensures that new people joining the project can quickly understand what they are working with. Ultimately, clear documentation minimizes misunderstandings and reduces costly mistakes. Okay, let's talk about regression testing, a really important piece of the software development puzzle. Basically, it's all about checking that when you make changes to your code, like adding a new feature or fixing a bug, you haven't accidentally broken something that was already working perfectly fine. It's like a quality control check for existing features. We want to make sure everything still functions as expected. It helps us build more reliable software and gives us confidence when we release updates. Okay, so let's talk about acceptance criteria. Think of them as your checklist for a feature. They're the specific things that need to be true before we consider it finished and working correctly. They really help everyone involved, developers, testers, and clients, stay on the same page. They ensure the team understands exactly what done means. Acceptance criteria aren't just vague ideas, they should be testable. A good example is for a login feature. You might say something like, given I'm on the login page and enter valid credentials, then I should be successfully logged in, and if things go wrong, there's an error message. Basically, acceptance criteria remove ambiguity and make sure we're building what the client actually wants. Okay, let's talk about alpha and beta testing. They are both really important for making sure our software is solid before it hits the market. Alpha testing happens internally. That means our own development team is putting the software through its paces. It's like a backstage rehearsal where we're looking for big problems and usability issues. Then comes beta testing, which is when we release the software to a small group of real users outside of the company. They'll be using it in their everyday lives, so they can give us valuable feedback on how things are actually going from a user's perspective, identifying bugs we might have missed and suggesting improvements. Think of alpha as internal checks and beta as getting honest opinions from the people who will eventually use it. Let's talk about how understanding your customers' feedback really changes things in the SDLC. Think of it as a continuous loop from the very beginning, when you're figuring out what people actually need, all the way through to making sure they're happy with the final product, and even after that. Customer input helps refine those initial requirements, ensures designs are usable, catches problems early in development, and guides improvements long after launch. It's not just about getting a yes or no, it's about really understanding why someone wants something, and how they intend to use it. Okay, let's talk about how we measure success in software development. Think of KPI, key performance indicators, as the yardsticks we use to see if our SDLC is really working. We're looking at things like cycle time, which is basically how long it takes to get a feature done from start to finish. Lead time is similar but looks at the entire process from initial request to delivery. And there's throughput, how much work we're getting done in a given period. Defect density tells us about the quality of our code, and customer satisfaction is vital. Are we meeting customer needs? Finally, team velocity helps us predict what we can accomplish in future sprints. It's really important to pick KPI that actually matter for your company's goals and keep an eye on them. They should evolve as things change. Let's talk about how DevOps is changing the game when it comes to building software. The traditional SDLC was a fairly rigid process. You planned, designed, built, tested, and then deployed. But that could take a long time. DevOps really shakes things up by breaking down those silos and automating as much as possible. Think about planning tools like Jira. Let teams collaborate constantly, so feedback can be incorporated immediately. Coding gets faster with CI/CD pipelines automatically building and testing code. And testing isn't just at the end, automated tests run all the time. Finally, deploying becomes a streamlined process thanks to infrastructure as code, meaning you can quickly spin up environments that are consistent across development, testing, and live systems. It's all about faster feedback, better quality, and happier teams. Okay, let's talk about baselines. They're super important in project management and how we track progress through the SDLC. A baseline is basically a save point for your project. It's like taking a snapshot of things at a particular moment, what you've agreed to deliver, when it needs to be done, and how much it should cost. We often have baselines for scope, that's what we're actually building, schedule, the timeline, and budget. They help us track if we're on track, manage changes effectively, and stay accountable throughout the whole process. Okay, let's talk about code review. It's a huge part of building solid software. Basically, it's when another developer takes a look at your code to find potential problems before they become bigger issues. It's not just about finding bugs, it also helps ensure the code is readable, maintainable, and follows our team's guidelines. Code review typically comes after you've written the code yourself and done some initial testing like unit tests, but before you start more comprehensive integration testing. It really sits right in the middle of development and testing, acting as a vital quality control checkpoint. Okay, so let's talk about security within the SDLC. It's absolutely crucial that we think about threats and vulnerabilities from the very beginning, right in the requirements phase. This means understanding what regulations apply to your project, like HIPAA or GDPR. Then, during design, we need to build security into the architecture itself, using principles like only giving users the access they truly need and always layering our defenses. During coding, following secure coding standards is key, along with having others review your code for potential issues. Testing isn't just about functionality, it needs to include dedicated security tests too. And finally, when deploying and maintaining, we have to monitor for new vulnerabilities and make sure everything stays patched up. A strong incident response plan is also vital. Let's talk about traceability matrices. They are a super important tool in SDLC. Think of them as a detailed map connecting everything related to your project. Basically, it's a spreadsheet that links requirements right down to the code in tests. It shows how each requirement is addressed by the design, then implemented, and finally tested. This helps teams ensure they haven't missed anything crucial during development, making sure every piece of functionality directly relates back to its original purpose. Okay, let's talk about user acceptance testing, often shortened to UAT. It's the absolutely crucial last step before you release a new software product. Basically, it's where real users get their hands on the system and try it out. We aren't just looking for bugs here, we want to make sure this thing actually solves the problems our customers have and does what they need it to do in their daily work. Think of it as a final "does this work for me?" check. It differs from other testing types, like unit or integration tests, because it's focused on usability and whether the software truly delivers value to the end user, using real data and workflows. Okay, let's talk about picking the right SDLC model for a project. It's really important to get this right, because it can make or break a project. First, think about how big and complicated your project is. Smaller projects might be fine with something straightforward like waterfall, while larger ones often need a more flexible approach. Next, consider how stable your requirements are. If they're pretty locked down, waterfall could work well. But if things are likely to change, agile is usually the better choice. Then look at your team. Do they work best when they can figure things out on their own? And finally, think about how quickly you need to get this product or feature to market. Agile's faster cycles are great for iterative products. Okay, let's talk about what's really shaping how we build software these days. It's not just about sticking to the old waterfall model anymore. DevOps practices where development and operations work hand in hand are absolutely vital for delivering updates quickly. Low-code/no-code platforms are also gaining traction, allowing teams to build apps much faster. And don't forget about AI, it's starting to help us write code, find bugs, and even understand what users actually need. Plus, building applications specifically for the cloud using things like microservices and containers is becoming the standard. Finally, we're seeing more automation through robotic process automation and intelligent tools. Thank you for watching.